Today we're looking into second order linear homogeneous ODE. Yes, when we say second order, we're doing something like this, having y prime prime, or you say something like this, the square y over the x squared. This means second order. Yeah. So quickly, let's look into an example of second order linear ODE that is homogeneous. All right. If I have y prime prime minus 5y prime plus 6y equal to 0. This means equal to 0 means homogeneous. Equal to 0. If there is something here that is not 0, it means non-homogeneous. Yes. Now, this second order we are seeing on the board has constant coefficients. We will learn first for constant coefficients, then we'll learn for variable coefficients. Here we have the coefficient of our derivative here is a constant, minus 5. Also, the coefficient of our derivative here is 1, which is also a constant. Assuming I have here 5x, it is no more constant coefficient. It's not called variable coefficient. So first, we shall learn how to deal with constant coefficients for homogeneous ODEs. Yeah, and it's simple. So let's do this. How do we solve equations like this? For this equation, this solution to this ODE is one of the simplest one. Provided you can solve a simple quadratic equation, you can handle this. Yes. All you do is just to get your auxiliary equation. Yes. How do you achieve this? You start by saying, let y be equal to exponential mx. You can use ax, you can use tx as your assumption. I love m, I use mx. So here we have, if y is this, my derivative for y, that is my y prime, what will it be? It's going to be, to differentiate this, right? If I differentiate exponential, I will simply take here down first. Differentiate mx, what do you have? You have m. Meaning I will have m, differentiate the power, we have m. Yes, then we'll not repeat everything here. That's how E works. That's how E works. If I give you differentiate exponential sine x, provided is E, you simply differentiate the one on top. What will it give you? Cos x. Differentiate sine x, that was cos x. So the entire stuff becomes just cos x goes to the front. Differentiate the power, the answer goes to the front. That's the answer for the derivative. If I give you now exponential, let's say 10x, and I say differentiate this, what's the answer? Without even solving, you know the answer, which is go for the power first. We have 10. Total answer becomes 10 exponential 10x. That's how E works. Having known that, let's go again. Let's differentiate and get y prime prime. Can we? Y prime prime simply means differentiating the second time. Yeah, So how do I achieve this? It means I have to go and differentiate my y prime to get y prime prime. In this case, m is a constant. Yes, m is our constant. So what do? We'll differentiate the power once more. If I differentiate the power now, what will happen? This m will jump out. Yeah, that's the idea. Each time you are differentiating the exponential function, you go straight to the power and differentiate the power. Once you do that, mx will give us m. When the m comes, we'll place it in the front, and that's all. So we'll place the m in the front. I mean, the m that will jump out from the power upon differentiation. We'll place that m in front here. That comes to m squared. Yeah, m times m, that's m squared. We'll be having m squared exponential mx. That's it. This is what you will have always. Always, you must have your y prime and y prime prime as this. So what do we now do? We simply go ahead and put them. Can call them equation. Can call this one equation star. Here equation 1. Here equation 2. Here equation 3. So what do? You put in equation 1, 2, and 3 into where? Into star. This is the main equation given to us to solve. If we do this, we are going to have it to become, instead of y prime prime, we have m squared exponential mx. Right? Yes. Minus 5. What's y prime? Y prime is m exponential mx. Right? Yes. Plus 6. Y, what's y? Exponential mx equal to 0. That's it. That's it. That's it. So what do we do next? We simply factorize what is common in these 3 terms. What can you see in the 3 terms that is common in the 3 terms? Exponential mx. Thank you, Sam. Exponential mx is everywhere. We'll factor it out. When we factor it out, what will happen? If I factor out exponential mx, what are we going to have left? We'll have left here m squared. Here minus 5m. How about here? Factor out, remove this thing from here. What do we have? Plus 6 equal to 0. Yeah. So you know how this thing works. When 2 numbers are multiplying themselves to give you 0, it's either exponential mx is equal to 0 or m squared minus 5m plus 6 is equal to 0. But this one here can never give you 0. You can't have 0 as an answer from the exponential function. Therefore, this here will equal to 0. I'll call this the auxiliary or complementary solution equation. Yeah. So once you obtain your complementary equation, you are good to go. It is no longer an equation containing what? Derivative. It's a simple quadratic equation which you can handle at ease. When you solve this, it's simple, you factorize. M squared, M here, M here. Yeah. So, two numbers you multiply to have 6. When you add them, you have -5. Two numbers you multiply to have 6. When you add, it gives you -5. What's that? I think it's -2 and -3. So M is equal to 2 or M is equal to 3. With this, you have a solution to be y is equal to C1 exponential 2x plus C2 exponential 3x. That is our solution. Now, we have solved it, yes. When we solve this, we'll have this. Yeah. I know that you are clear on everything so far, except the answer, except our final answer here. The final answer puzzles you a bit, but we'll explain. After solving your equation that we call auxiliary equation or complementary solution equation, you are going to have two values for m. Those two values of m, you will not use it to write your solution. Now this thing centers on the nature of root of a simple equation we call quadratic. Now, nature of roots can be real and distinct. It can be real and equal. Also, it can be complex roots. So there's a way we write answers for each of these things. After solving a quadratic equation, after solving it, your answer must be two things. Like here we got 2 and 3. Real, and they are different answers. In this case called real and distinct. If you solve this one, if you solve m squared minus 6m plus 9 equal to 0. If you solve this equation, your m is going to be 3 twice. In this case, it's called real and equal roots. Yeah. So if you solve this, m squared minus 6m plus 34 equal to 0. Yeah, you have your m to be 3 plus 5i, or 3, let's say 3 plus or minus 5i for your two solutions. Now, I want to show you how to write the solutions. Let's start. with real and distinct. Alright, let's say we have to solve this. The first thing that comes to your mind is, what equation is this? This is second order linear homogeneous ODE of constant coefficients. How do we solve it? First, we are not using the long process for now. Let's learn how to write the solutions first. I've shown you how to solve it formally, just like in your exam. So now, I will teach you how to picture the auxiliary equation and how to write the solution. Yes. So, when you have this turns to m squared minus 3. This turns to m plus 2. Here we have no m. Only your y prime prime and y prime takes the m squared and m respectively. The next thing you do is to solve this thing. When you solve this thing, your m is going to be 2 or 1. 2 or 1. Yes. When you solve this, m is 2 or 1. Now, if your m is 2 or 1, this solution, is it a real and distinct, or real and equal, or complex? Remember, I have 3 possible nature of fruits for a quadratic equation. So tell me, this my auxiliary has 2 and 1. What is my nature? Real and distinct. In a case like this, your y is going to be C1 exponential 2x plus C2 exponential 1x, which is still what? X. And that is my solution. When you solve second order, you have 2 constants in your solution. Now, what if we solve something else? If I solve y prime prime minus 4y prime plus 4y equal to 0. To solve this, I'll first of all picture my auxiliary equation. And that will be, that will be m squared minus 4m. Please, are you following? Yes. 4m plus 4 equal to 0. Now when you solve this equation, solving this is just a simple thing. Those of you that know maths very well, from JS3 itself, you can solve a simple equation like this, quadratic. So when we solve this, our m is going to be 2 twice. Yes. In this case, we have 2 answers. Says every quadratic must give us 2 answers. Yes. 2 twice. In this case, how do we write the solution? It's going to be y is equal to C1 exponential 2x. Yes. Plus C2 exponential 2x. Okay, so I hope you are following. Now, actually, this is meant to be like this. If we use the mentality we have from this place, which you are thinking, yeah. I know you're thinking the same thing, Tunde. You are thinking that this and this will be like this. But no. This and this being like this will overlap. I can join this with this. In that case, there is no C1 and C2. I have only one constant, making it a solution to first order equation. So what do we do? Every time you have real and equal roots, repeated roots, what do? You have to add x to one of the constants. So here is C1 exponential 2x plus C2x exponential 2x. If you have 5 twice from your solution, this one, what will it be? It will be that y is equal to C1 exponential 5x plus C2x exponential 5x. We put in the x to avoid the terms from overlapping. Yes. So quickly, let's look into the third nature of root, which is complex roots. This question can appear in these two forms: prime notation, Leibniz notation. So in this case, what do? If you are given like this, all you do is you fetch the auxiliary. When you obtain the auxiliary, you solve it and get the value of your m. So yeah, if I should construct my auxiliary here, I'll have m squared, right? Yeah, m squared minus 4m, yeah, plus 13 equal to 0. I would have loved to teach you how to solve a simple quadratic equation, but we don't have that time in this video. So when I solve this, when we go ahead and solve this auxiliary, what happens? We shall obtain m to be equal to 2 plus or minus 3i. Now I will show you how to write the solution when you have complex roots. Whenever you have I in your solution to your auxiliary, it means that you have a complex root. So in this case, I will show you how to how to write the solution. My solution here is going to be y is equal to exponential 2x for the real parts. The real parts, imaginary parts. Real parts, imaginary parts. So you have exponential 2x. 2x. This 2 is based on the real parts. You open your brackets. You write C1, the first constant. C1 sine 3x. This 3 is based on the 3 we have in this part. Plus C2 cos 3x. And that is our solution. The real part goes with E outside the bracket. And the other part goes this way inside the brackets. I hope this class was very helpful to you, and I hope you learned this. We will do more of this when we solve non-homogeneous constant coefficients. Check the Learnextra app for more examples. Thank you for watching.